Hi guys, welcome back for chapter 5 part 2. Let's start with the first one, which is the sampling distribution of the sample mean. So, there are two properties of the sampling distribution of sample mean. First, the mean of sampling distribution, which is mu of x bar, is equal to the mean of sampled population, which is mu. This one is for population. This one is mean of sampling distribution. Next is the standard deviation of a sampling distribution, which is here, will equal to the standard deviation of sample population divided by square root of the sample size. For the standard deviation of the sampling distribution is often referred to as the standard error of the mean. Standard error of the mean. Let's move on to the next part. The next part is the central limit theorem. Consider a random sample of n observations selected from a population in any probability distribution with mean and standard deviation. Then, when n is sufficiently large, the sampling distribution of x will be approximately a normal distribution with the mean of sampling distribution is equal to mean of sample population, and the standard deviation of the sampling distribution is equal to the standard deviation of sample population divided by square root of the sample size. When I say is sufficiently large, it means that the sample size have to be more than or equal to 30. The larger the sample size, the better will be the normal approximation of the sampling distribution of x bar or mean. For example, I have 36 observation and the mean is 80 and the standard deviation is 6. So if I want to find the probability of x bar will be more than 82, we have to find it by use z-score. So first we have to convert from this one to standard deviation of sampling distribution first. So first we have 6 divided by square root of n, or 36. This one will be equal to standard deviation of sampling distribution based on this one. So this one will be equal to 1. And the next step, we can find the z-score by use the formula, which is x bar minus mean divided by standard deviation. So it's gonna be equal to 82 minus 80 divided by 1, which is equal to 2. So on the z-score table, 2 is equal to 0.4772. When I said that p of x more than 82, it means that z is more than 2. So it's gonna be this part on the curve. This one is 2. It's gonna be this part. So as we learned from the last video, mu is equal to 0, and then from here to here is equal to 0.5. So the probability of x bar is more than 82 will equal to 0.5 minus 0.4772, which is equal to 0.0228. So let's move on to the next one. The next part is the sampling distribution of the sample proportion, or p hat. The first property of it is mean of the sampling distribution, or p hat, will equal to the true binomial proportion, or normal p. The next one is the standard deviation of the sampling distribution, or the sigma of p hat, is equal to square root of p times q divided by n. And q is also can be 1 minus p. The last part is for the large samples, to make the sampling distribution is approximately normal, it's going to be n times p hat have to be more or equal to 15, and n times q hat, it has to be more than or equal to 15. Both of these have to be true. They are the requirement of the large samples. The next video is going to be assignment for chapter 5. See you in the next video.